Now, the number one on the list of the four quantum number is the principal quantum number. This number suggests that the electrons are arranged in shells or levels. This is in accordance with Niels Bohr model of atom, which depicts that electrons are kind of found in a closed circle, kind of a ring-like shape, like as we know about the nine planets. So for this, the principal quantum number tells us the level where the electrons occupy. So it is believed that the electrons that are closest to the nucleus are said to occupy level 1. They are given the principal quantum number 1 because they are closest to the nucleus. As we move away from the nucleus, the principal quantum number increases. So we can see that the principal quantum number is simply an integer which runs from 1, 2, 3, 4 up until infinity to describe the level where the electrons can be found at the moment. So some electrons are said to be, that are closest to the nucleus, are said to be labeled the number 1. The ones that are a bit away from the nucleus, number 2, and so on and so forth. Now, it's also been noted that each of these numbering has a corresponding alphabet that is attached to it. So the first shell is called the K shell, the second shell is called the L shell, the third shell is called the M shell, the fourth shell is called the N shell, and so on and so forth. So from what we've gathered here, the principal quantum number arrange the electrons in shells, and each shells have a given number of electrons that it is permitted to handle. And to know how many electrons that a particular shell is expected to handle, we use a general formula 2n raised to the power 2 to determine the maximum amount of electron each shell can hold. So the n there represents the principal quantum number. So for the K shell, which is the first shell, we know that the maximum electron that it can hold there can be given as 1 raised to the power 2. And when we do the math, 1 square is 1. 1 times 2 will give us 2. And the next shell, which is the L shell, is the number 2. If we repeat the same mathematical operation, we will discover that 2 squared is 4. 4 times 2 is going to give us 8. And the list goes on. We can do that for the M shell, so that we're going to have the same thing, 2 into 3 squared, and we have 18 when we do the math. So this whole figure here obtained are the maximum amount of electron that a particular shell is permitted to have. And this is very, very cool because it gives us an overview of how the electrons, where the electrons, or how many electrons that a particular shell is expected to have. So let's say we want to draw the atom of aluminium, for example. So using the principal quantum number. Aluminium has an atomic number of 13. And what that means is that it has 13 protons and 13 electrons. So our interest is on the electrons. We already know that the protons is on the nucleus, so that is not a problem. But the ones we need to try and make right is the electrons. So here we need to configure these electrons around the nucleus of the atom following the principal quantum number. So according to the principal quantum number, we definitely need to draw our nucleus. So inside the nucleus, we are expected to have about 13 protons of aluminium. Then the electrons, which is 13 as well, we start configuring them as follows. So we draw the first shell, which is our K shell. And according to our K shell, the maximum electron that should occupy there is 2. So I just need to drop 2 here, and I move on with the rest. So it means 2 electrons occupy the K shell. Then we move to the next shell. The next shell on the list is the L shell, and the second shell, which has a maximum electron of 8. So, but I still have up to 11 in my hands. So I can drop 8. That is all I have to drop at this shell. So I'm just going to drop it like that. So let me drop them singly before pairing. So that is it. So I've dropped 8 electrons here. So currently the total electron that I've dropped, I've configured is 10. I still have 3 more to go. Then it means that I can no longer drop these 3 more here because this shell is complete. Then I move to the next shell. So the next shell is the M shell. This shell takes a maximum of 18 electrons, but what I have left is 3, so I just have to drop the 3 there, and that is it. So what you are looking at is the electron configuration of aluminum using the principal quantum number. So if we are to summarize the whole arrangement, we can simply say that according to the principal quantum number, each shell has a particular amount of electron that it is permitted to have. So for the K shell of aluminum, for aluminum sake, the K shell occupies 2 electrons, has 2 electrons there. The L shell has 8 electrons, and the M shell has 3 electrons. So this becomes the summary of the electron configuration of aluminum. So feel free to draw as many electron configuration of atoms as you can. So that is for the principal quantum number. So I will see you for the next quantum numbers.